Welcome back. The objectives of this video is to introduce Pascal's triangle. We're going to define a binomial coefficient and introduce some probability concepts, and we're really laying the foundation for the binomial theorem and binomial expansion. When writing out a binomial expression, so a binomial meaning just two terms raised to some power, where n is a positive integer, the pattern known as Pascal's triangle appears, as well as other interesting facts to be discovered. In order to expand the binomial expression, we need to know how to find the binomial coefficient. So one of the things we could do is we could just FOIL this over and over and over again and expand this out. But it's easier to learn how to do a binomial expansion. So the binomial coefficient is, well, the coefficient on a particular term, and we'll use the expression n above r is called the binomial efficient. And n above r is equal to n factorial, so exclamation point is a factorial symbol, all over r factorial times the quantity n minus r factorial. And we'll often use the symbol C for combination. The symbol NCR is often used in place of the n over r notation. And these functions actually can be found on your graphing calculator. So if you open up your graphing calculator, these probability functions can be found in the math menu. So on the math key over here on the left, I select math, and prob is probability, so I'll cursor over to probability. And you can see here the third item, NCR, the combination of n items, choose R, that's what that means, and the factorial symbol are there. So we'll come back and we may use these, but they're in your calculator and handy for you to apply. The factorial symbol now is simply a factorial means you're multiplying things together. So like 6 factorial is equal to 1 times 2 times 3 times 4 times 5 times 6. So when you get your grade, if you get a really good score on a test, say you get 56 out of 56, I'm not going to be like, hey, great job, 56, and put an exclamation point next to it, because that would be 56 factorial, and I don't want to mislead you on how great of a grade you got there. So let's take a look at some samples, and we'll evaluate each of the following of these. So 6 over 2, or you could see this as the combination of 6 choose 2, or n over r. So our n is 6, so we have 6 factorial all over 2 factorial times 6 minus 2 factorial. So 6 factorial over 2 factorial times 4 factorial. Well, 4 factorial is going to cancel here. Watch this. So 6 times 5 times 4 factorial is the same thing as 6 factorial. And then I have 2 factorial is just 2 times 1, and all over 4 factorial. So my 4 factorials cancel, and I get 6 times 5 over 2, which is 30 over 2, and I get 15. So our answer here for the combination of 6 choose 2, or 6 over 2, is 15. If I wanted to use my calculator to do this, again, I'd go into the math menu, I'd cursor over to probability, I'm going to choose item 3, and this just gives me 6. I can put 6 in, and the combination of 6 choose 2, and I hit enter, and it gives me my answer of 15. So in the second sample, I have 9 over 4, or the combination of 9 choose 4. So 9 factorial over 4 factorial over 9 minus 4 factorial. So that's going to be 9 times 8 times 7 times 6 times 5 factorial all over 4 factorials, 4 times 3 times 2 times 1, and then all over our 5 factorial. So our 5 factorial simplify to 1. And now we can do some canceling to make our life a little bit easier here. What's going to be easy? The 3 and the 2 are going to simplify with the 6. The 4 and the 8 will simplify, and I end up with 9 times 7 is 56. No, it's not. 9 times 7 is 63. Times 2 is 126. And the last one, 3 choose 3. Combination of 3 choose 3 is simply 3 factorial over 3 factorial times 3 minus 3 factorial. The lesson here is 0 factorial is equal to 1. So 0 factorial is 1, so we end up with 3 factorial over 3 factorial, and that is equal then to 1. So 0 factorial equals 1. And here we have a representation of Pascal's triangle, at least the first 5 rows of it. And it can be used to find the values of the binomial coefficients. So the coefficients when we expand out our binomial or we FOIL it all out. And it can be, and we can use that for our coefficients. So Pascal's triangle has all ones on the outsides, or I would say on the left side and the right side. And then as you can see here, the second one, we have 1, 2, 3, 4, 5 going down diagonal. The next value there is going to be 6. The next value is going to be 7. And same thing other side as we go down the right diagonal, 1, 2, 3, 4, 5. And then that one would be 6 and that one would be 7. These would still be 1s. And then it looks like in our third, we would add 2. 1 plus 2 is 3. 3 plus 3 is 6. We'd add 4. We'd probably add 5 and so forth. So, and that's going to work the same way going the other way. And here we add 3, and here we add 6. So there are some patterns to be found in Pascal's triangle. So I've got a kind of a cutout of Pascal's triangle here, which would tell us what our coefficients are in our binomial expansion. So if I had x plus y raised to the 4th power, I'm going to have decreasing order of x starting at 4. So I'm going to have x to the 4th, I'm going to have x to the 3rd, I'm going to have x to the 2nd, I'm going to have x to the 1st, and then I'm going to have x to the 0. So I'm not going to put that there. And then I have descending order of y, so at the first one, at x to the 4th, that's going to be y to the 0 is 1, and then this one will be y to the 1st, y to the 2nd, y to the 3rd, and my last one will be y to the 4th. So I'm going to have 1, 2, 3, 4, 5 terms in a 4th degree binomial expansion here. I've got my x's and y's, and now I just need to put my coefficients in, and I can snag those from Pascal. So the coefficient on my leftmost term, or highest degree x, is 1. The next one is 4. The next one is 6. The next one is 4. The next one is 1. Since this is plus, these are all positive. And I can follow the same pattern for x plus y to the 5th. So I'll have x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x to the 1st, and then x to the 0. And then my y's, y to the 0, and then y to the 1st, y to the 2nd, y to the 3rd, y to the 4th, and y to the 5th. Oops, y to the 5th. Okay, so there's my 6 terms. Decreasing order of x, increasing order of y starting at 0, and then I can put my coefficients in 1, 5, 10, 10, 5, and 1, and then they're all plus. So a little messy, but instead of foiling that out, I used Pascal's triangle to do the binomial expansion for a 4th and 5th degree binomial. And we'll get a little more practice with this when I see you in class.